Hello, my people. This will probably be the final video for 5.3. I think 2 videos on the second fundamental theorem of calculus is probably enough. But let's just review what I covered in the last video. We know that when you're taking the derivative from a to x of f of t dt, that the derivative of that is just f of x. And that should make sense just kind of intuitively the moment that you realize that differentiation and integration are inverse operations, for the most part. And if you're going from a constant not to x, but to an expression in terms of x, or a function of x, it just winds up being the chain rule. So it winds up being f of u of x, and then you just have to tack on a u prime at the end. Those are the 2 forms of the second fundamental theorem of calculus. So that's fun. Let's go ahead. And the great thing about this is that you don't even have to be given a function that is integrable. Okay, it's a hard word to say. Always have a trouble with that. Integrable. Okay, meaning capable of being integrated. If you're given something that is not integrable, let's say we have, oh gosh, I don't know, how about f of x is equal to, and this might be integrable, but certainly not easy, t to the 4th plus 1 dt, or something like that. Or even, let's go ahead and put an extra t out there to make it even more difficult. So if I'm given something like that, and actually that may actually be integrable, I don't know. I would have to think about it for a second. But if we're given something like that and we're asked for f prime, the great thing about this is we don't actually have to integrate this to go straight to the derivative. The derivative, because those are inverses, whether the original integral and whether the original integral is integrable or not, yeah, say that 5 times fast, we can wind up here for f prime. Okay, and that's significant. If we're given something like, and the only other thing that we dealt with here was when it goes, instead of from a to x or a to u of x, when it goes from one expression of x to another expression of x. And we'll do one of those here in just a few minutes. But let's say we're given f of x is equal to, I don't know, let's say 3 to 3x of sine x dx, or something like that. Okay? Well, I mean, f prime of that winds up being really easy, okay? Because while it is of this variety, the u of x is so simple. The u of x is just 3x, that it winds up being, oh, sorry, this should be, oh gosh, this should be sine of t dt, okay? It just winds up being sine of 3x times 3, okay? You take the u of x and you drop it in for the t, and then you just have to tack on a u prime, okay? So this right here is your f of u of x, and this right here is your u prime of x, right? Because this right here was your u of x. Okay? It was not x, it was an expression in terms of x. All right. That looks like a good one. How about f of x is equal to 0 to x of t squared plus 1 dt. And this one actually is integrable, because you could distribute the t, but let's go ahead and do f prime of x, and all we have is x squared plus 1. Well, every once in a while I like to do it the long way, just so people, continue to believe me. Well, let's go ahead and do that from 0 to x of t cubed plus t dt. And that winds up being 1/4 t to the 4th plus 1/2 t squared from 0 to x. And then that winds up being 1/4 x to the fourth plus 1/2 x squared, and then when you plug in 0, it winds up being, just minus 0. So if that is f of x, what is f prime? Well, isn't it just that? Because isn't that x cubed plus x? If you take the derivative of this, it's that, okay? But knowing the second FTC, you get to skip all of that. And of course, even better, if it's an integral that's not integrable, then, and you can't do this, you know that because they're inverses of one another, you can go straight from f of t dt to f of x, okay? Alrighty. Let's just do a few more. How about 0 to x squared of sine theta squared d theta. Now, don't mistake that for sine squared theta. Here, the function is not squared. The angle measurement expression is, okay? Well, what is f prime of x? Well, we're going to go ahead and just plug that in right there, and it winds up being sine x to the fourth. That is our f of u of x. What we have to do now is tack on a u prime. Okay? Alrighty. How about... Okay. How about f of x is equal to x plus 2 of 4t plus 1 dt. Okay? And I told you that we were going to get back to one of these. Now this is different because it's not a to u of x. You have both limits of integration have an expression in terms of x. Now thankfully they're relatively simple. I mean, this is just x and that's just x plus 2. But you basically have to say, okay, well, between x and x plus 2, there is some constant. And so that means that I can go ahead, and we'll call it k this time. Like I said, it doesn't really matter what it is. And so we'll split up the integral such that it's like this. Well, the problem is not here. This is really, really easy. The problem is here because it needs to be a to x, not x to a, okay? And so we have to flip the limits of integration around, and remember, of course, that the reason why when we flip the limits of integration we put a negative out here is because all definite integrals are implied differences. And when you flip the limits of integration, you flip the order of the difference. When you flip the order of the difference, you get a negative, right? 5 minus 2 is 3. 2 minus 5 is negative 3. Well, even when you're dealing with it in terms of variable expressions and not actual, known numbers, that, the principle still applies. So if that's still f of x, and all I've done up to this point is I've just changed the form of f of x. This is still f of x right here. Now I'm finally ready to go ahead and take the derivative. And so I get negative 4x plus 1, and this one winds up being 4x plus 2 plus 1. And I would normally put the derivative of u of x out here once I've done f of u of x. The thing is that the derivative of x plus 2 is 1. So, I mean, it's sort of a non-issue, right? Tack on the derivative of that u of x. Boom. Well, here that becomes, of course, negative 4x minus 1 plus 4x plus 8 plus 1. Boom, 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 boom. Your answer is 8. Okay? We'll just do a few more, and then we'll sort of call it quits. I just want you to know and just be comfortable enough with this, such that you don't feel shortchanged when it comes time for the test. Now, remember when I talked about ones that you don't know how to integrate, or at least don't know how to integrate yet? Okay, 0 to x of t cosine t dt. What is f prime of x? Because this, you can't actually integrate this. The BC kids will actually learn this. You'll actually know how to do that fairly soon. It's a process known as integration by parts. The AB kids will have to wait until Calc 2, if you ever wind up taking Calc 2 in college, to actually know how to integrate that. But if f prime, you just basically plug in x for t, right? So it ends up being x cosine x. Okay, well, let's use that same integrand, and let's do 0 to x squared of t cosine t dt. What is f prime of x? Well, again, the way that I plugged x in for both t's, I'm going to plug x squared in for both t's. Okay, now fight the urge to put the derivative of x squared out here twice, okay? Because this right here is f of t. Okay, you're only plugging it in once. It just happens to be that there's two places to plug it in, okay? And so it's still just a 2x out here. And of course, you can simplify this because that combines with this factor out here. It becomes 2x cubed cosine x squared. Okay, well, what if I have f of x is equal to 0 to, how about this? Arc sine of x of t cosine t dt. I know, I'm evil. How about f prime of x? Okay, well, let's just go through the method, okay? We're going to plug in arc sine of x, which is our u of x, our expression, in for both t's. So we have arc sine of x cosine of arc sine of x, and then I need to do the derivative of arc sine of x, 1 over the square root of 1 minus x squared. And if your teacher's, if your teacher's a bit of a stickler, she may ask you to simplify that, which you should know how to do, right? You just do a simple triangle over here. We'll call that alpha, which is, of course, what the arc sine of x represents. If that's the case, then your ratio is x over 1, opposite over hypotenuse. This winds up being 1 minus x squared. So basically, this right here is going to be cosine of that alpha. So it's 1 over, or it's adjacent over hypotenuse. So this winds up canceling with that, right? So you get just arc sine of x. Kind of cool, huh? Okay. So that winds up being f prime. I think that's really all that we're really going to need. I mean, once you've done the first fundamental theorem of calculus, the second being basically a corollary, or they're sort of corollaries of each other, winds up being relatively simple. Once you sort of state the second fundamental theorem in terms of the first and run through a couple of examples of how doing it the long way sort of bears out the results of the formula makes a whole lot of sense. You wind up remembering it a whole lot easier. There's basically, I mean, it's not really all that complicated. The only things you have to remember is the originals, these two, okay? This is the original just with x. This is the original just with u of x. And then you're occasionally going to have an example like this, where you go from one expression of x to another. Well, split them up with some constant k. The one that's out of order, flip around and tack a negative out in front, and then just differentiate both of them, basically run through the formula for both of them, and simplify. Okay? If you have any questions, like I said, go ahead and email me. I do want to make sure that you have enough resources in order to do well in the quiz and or test, but I don't want to make the number of videos burdensome for you. So I think for 5.3, 5 short videos is enough. If you need more, of course, please do email me. Those of you who have already told me that you're going to be showing up for the Skype session on Saturday, thank you for doing so. Those of you who have not, please let me know. It is really useful. The Skype sessions are incredibly helpful for those that, or at least the feedback that I'm getting, is the fact that they're really, really helpful for those that have shown up. So please, please do make an effort to do that. And of course, I will do my best to prepare you for the upcoming test on Chapter 5. Look in the near future for videos on 5.4 and 5.5. There will be quite a few on 5.5 because 5.5 is a bit robust. It basically is the undoing of differentiation rule, the chain rule, basically. It's the integration undoing of the chain rule, which winds up being a little bit nasty at times. So we'll have fun with that when the time comes. Bye.